When doing Laplace transforms, after you get through the basics like I've shown in the last two videos, you might be given a sheet that looks something like this. Let me see if I can zoom in here. This will give you some generalizations that we can infer from going through all the math before, and you come up with some general formulas, and I'll write down how these work. So the formula sheet says if we have something that is the sine of kt is equal to k over s squared plus k squared. So this works, there we go. If we plug in a number for k here, these k's on the right side get turned into whatever this is. So if we have sine of 2t, this is going to equal 2 over s squared plus 2 squared, which is equal to 2 over s squared plus 4. And this is always going to be the case for any number that we can plug in here. If we plug in something like sine, I don't know, 300t, you just plug this 300 into all these places, and you get your answer over here on the right side, an answer with respect to s. Another example would be e to the at cosine k, that's a terrible k, kt. Alright, and we're given that this is equal to s minus a over s minus a squared plus k squared. Now in this time we have two different variables. This a over here is one variable that can change, and this k right here is another variable that can change. So for instance, if we have e to the 3t cosine 5t, we just need to take these variables right here and plug them into the right side. So we're going to get s minus, our a over here was 3, and let's see, we'll bring this down, s minus a again, so this a is 3, and that is all squared, plus k squared, our k is 5, so that's going to be 5 squared. So once we do the math here, that's going to be s minus 3. We can choose to factor that out or not. I don't know if your teacher will require you to factor that out or not. Plus 25. And this would be the answer to this Laplace. So you'd be given the Laplace of this right there, asked to find the answer, and this is what your final answer will be.